You know, Alex, there's a very specific sound that haunts a man's dreams. It's not a ghost or a bump in the night. It's that high-pitched harmonic shriek of a carbide bit vibrating at 20,000 RPMs right before it snaps into 1,000 tiny expensive confetti pieces.
Well, good morning to you too, Tiger. I take it you've been consulting with the CNC machine again?
Let's just say I was trying to convince a piece of white oak that it wanted to be a topographical map, and the oak had other plans. I got a little overeager with my settings. It's that classic trap where you think, I can shave 10 minutes off this run, and instead, you spend 2 hours picking splinters out of your hair and ordering a new $60 bit.
The siren song of the fast button. It gets the best of us. But that's actually perfect for today, because we're diving into the brain-melting world of CNC for beginners, specifically the Holy Trinity: feeds, speeds, and toolpaths.
It's the stuff that makes people's eyes glaze over until they actually see the machine move. Then suddenly they realize they're basically piloting a robot with a spinning knife on the end.
Okay, let's start at the very bedrock. For someone who's only ever used a handheld router, the kind where you can actually feel the wood fighting back, how do you explain what's happening in a CNC?
It's a transition from haptics to mathematics. When you're holding a router, your muscles are the feedback loop. You feel the vibration, you hear the motor bog down, and you naturally slow your hands. With a CNC, the machine is a cold, unfeeling beast. It will try to push that bit through a brick wall if you tell it to. It's a subtractive process. You're carving the masterpiece out of the block, but you're doing it through a series of coordinates.
Right, the X, Y, and Z. But the machine doesn't know if it's cutting butter or granite unless we tell it, right?
Exactly, and that's where people get into trouble. They treat the software like a set it and forget it's slow cooker. But if you don't respect the material thickness, and I mean measuring it with calipers, not just trust what's printed on the label, you're going to end up gouging your spoiler board, or worse, snapping the tool because the wood was a 16th of an inch thicker than the file thought.
I've seen you do that. You hover over that machine like a nervous parent at a piano recital.
Because I know the stakes. You see, the big mysteries for beginners are speeds and feeds. And they sound like the same thing, but they really aren't. Speed is how fast that bit is spinning, the RPM. Feed is how fast the machine is moving that spinning bit across the table.
It's a delicate dance. If the bit spins too fast but moves too slow, you get smoke. If it moves too fast but spins too slow, it just breaks.
You hit the nail on the head. If you're just sitting there, spinning at 18,000 RPM but only moving at a crawl, you aren't cutting, you're friction cooking. I once turned a beautiful piece of cherry into a localized campfire because I didn't understand that the bit needs to move fast enough to pull the heat away in the chips. That's what chip load is. It's the actual thickness of the slice of wood each flute of the bit takes off.
So the chip is actually a cooling mechanism?
That's the secret. Now, if your dust looks like actual flour, you're killing your tools. You want little curls, you want grit. If the chips are taking the heat away, your bit stays cool. If you're just making smoke, that heat stays in the carbide, it loses its edge, and then snap.
Okay, so we have the speed of the spin and the speed of the travel. Now let's talk about the map the machine follows, the toolpaths. I keep hearing about pockets and profiles. What's the difference for the person sitting at the computer?
Think of a pocket like digging a swimming pool. You're clearing out an area to a certain depth, but you're leaving the floor and the walls of the wood intact. A profile is like a cookie cutter. You're going all the way through to cut the shape out of the board.
But you can't just dive in and cut a 2-inch thick piece of maple in one go, right?
Oh, heaven forbid, no. Unless you want to see sparks and hear a sound like a dying banshee. You have to take it in passes. Usually, a good rule of thumb for beginners is to never cut deeper than half the diameter of your bit in a single pass. If you have a 1/4-inch bit, don't try to go deeper than 1/8 of an inch at a time. It's like eating a giant sandwich. You got to take small bites or you're going to choke.
I like the sandwich metaphor, but what happens to the cookie when you finish the profile? Doesn't the part just go flying across the room once it's cut loose?
Ah, the projectile phase of learning. Yes, if you don't use tabs, which are just tiny little bridges of wood left behind to keep the part anchored to the scrap, your beautiful project becomes a wooden frisbee the second the bit finishes the circle. I've had parts fly off the table and nearly take out my favorite shop stool. Now I'm a firm believer in the 1.5-inch margin rule. Keep your work away from the edges and use plenty of tabs.
So let's talk about the software side for a second. You mentioned things like RhinoCam or Carvico. For a beginner, it looks like a flight simulator dashboard. Is there a cheat code to getting those settings right?
There's no magic button, but there are tool libraries. Most good software lets you import a library where someone much smarter and more patient than me, has already punched in the starting speeds and feeds for a specific bit. Use those as a baseline. But remember, the library doesn't know you're cutting some weird sappy pine you found behind the shed. You still have to listen to the machine.
Is it true you can tell if a cut is good just by the sound?
Absolutely. A happy CNC has a consistent low register hum. It sounds purposeful. If it sounds like it's screaming or if it's chattering, which is that stuttering vibration, you need to change something fast. Usually chatter means you're either going too fast or your bit isn't held tight enough in the collet.
Speaking of collets, I've seen people just shove the bit in and crank it. Is there an art to that?
It's not a lug nut on a truck. You have to make sure that collet is clean. One tiny speck of sawdust inside the collet can make the bit spin slightly off center. At 20,000 rotations, slightly off center becomes a jackhammer. Clean your collets, snap them into the nut before you put the bit in, and don't over-tighten them like you're trying to win a strength competition.
You mentioned conventional versus climb cutting earlier. That sounds like something out of a mountaineering manual. What does that mean for our beginners?
It's the direction the bit moves relative to the rotation. Think of it like a tire on a car. Conventional is like driving through deep mud. The bit is biting into the material and pushing the chips out behind it. It gives you a lot of control. Climb cutting is like the tire grabbing the pavement and trying to launch the car forward. It can give you a cleaner finish on some woods, but if your machine isn't rigid, it can grab the wood and jump. For beginners, start with conventional. It's just safer. It's the difference between a controlled walk and a controlled fall.
Okay, let's talk about the oh no moments. You've had your share. What's the biggest rookie mistake you see when someone finally gets their hands on a machine?
Not checking the Z0. They'll set their home position on the table, but then they change bits, which are different lengths, and they forget to tell the computer that the new bit is 2 inches longer. They hit start, the machine thinks it's clear, and it drives that bit straight through the workpiece and half an inch into the aluminum bed. It's a very expensive way to make a hole in your table.
I remember the first time I saw you do that. The tiger-sized groan was audible from the driveway.
Every craftsman has a scar on their machine that tells a story. That one taught me to always do a dry run in the air, lift the bit 2 inches above the wood, and run the program. If it looks like it's going to crash into a clamp, you'll see it before it costs you money.
That's a solid tip. So, to wrap this up, if someone is standing in front of their brand new, shiny CNC today, feeling absolutely terrified to hit that green button, what's the one thing they should keep in mind?
Don't be afraid to be a student. This isn't like a hammer where you just get it after 3 swings. CNC is a language. You're going to get some grammar wrong. You're going to burn some wood, and you're going to break a bit or two. But the first time you pull a perfectly carved, intricate part off that table, something you could never have done by hand, it's like magic. It's like you've suddenly gained an extra set of hands that never gets tired and never misses a measurement.
And maybe keep a fire extinguisher nearby, just for the friction cooking phases?
Couldn't hurt. And for heaven's sake, keep your vacuum on. Sawdust is the enemy of precision. If you're buried in chips, you can't see the disaster coming until it's already happened.
Wise words from the man who has graduated through many a broken end mill.
Hey, I'm just trying to make sure the next generation keeps their bits in one piece longer than I did. It's a beautiful craft, Alex. You just got to respect the math as much as the wood.
That's a wrap on our CNC deep dive. Go forth and make some chips. Just make sure they're the right size.
And remember, if it sounds like a jet engine, you're doing it right. If it sounds like a dying cat, hit the e-stop. Catch you next time in the Tiger Den.